Okay, welcome. So last time we were looking at a basic bouncing ball, which looked like this, and it was just kind of bouncing around, and we got it to deflect off the edges, we got it to move with a given velocity, which is great, but it doesn't look that interesting because we've got just this gray background, and it's a white ball with a black outline, and you see all the previous drawings of the ball, so it's just not looking that great. So in this video we're going to look at ways you could change the appearance of the ball, add some color to the sketch, and make it a bit more artistic and whatnot. So let's get right into that. So as you might remember, when we talk about colors with computers, we're thinking about red, green, and blue values. And each of those values ranges from 0 to 255. So if we wanted to color the ball, we could use this really cool function called fill. And that tells processing whatever I'm going to draw next, color it this color, and we give it the R, the G, and the B values. So for example, if you wanted to fill it green, you could say 0 red, 255 green, and 0 blue. And then if we run that, then every frame the ball will be green, which is great, and if you like green, that might help. But we could do some cooler things with the colors where maybe it's changing based on where the ball is positionally. So if we wanted to do that, where the color is actually changing each frame, then we're going to want to use variables for those R, G, and B values. So let's just create some variables up here at the top called R, G, and B. Float R, G, and B, that's fine. And then what we'll do is we'll use them down here. Instead of filling 0 to 550, which will draw green every single frame, we can just fill R, G, and B. And then when we change the values of R, G, and B, that'll reflect in what the ball actually colors itself as. So we can try that. If we start R, G, and B off at something, up here in setup, we can say R is 200, I'm just making up a random color, I don't know what this will look like. We can say 150, and then RPG, oh man, I reversed it. We'll do 10, and then see what that looks like. So it's kind of a pinkish, purplish one, but still, it's always the same color. So we're going to actually want to change the values of R, G, and B, right? So how can we do that? One really cool way to do it would be to scale maybe the red value based on one of the positions of the ball, so the X position, for instance. And we could scale the green value based on the Y position. And then blue we could scale based on maybe some combination of those two positions. So one thing that's super useful when we're scaling values, because that's what we're going to be doing, is the processing map function. So what map does is it takes a value that's within a certain range that you know, and it scales it onto a new range. So for instance, if we wanted to say red is going to be based on the X position of the ball, right? We can say R equals map, and then it wants to know what are we mapping, so we're mapping the X value, and then what is the range currently of the X value? Well, what is the smallest value of X? It's going to be 0, right? That's the left side of the window, and the largest value of X is going to be the width of the window, which we know is stored in the width variable. So we can say X from 0 to width is where it currently is, and we want to scale it onto 0 to 255, because that's the range for color values, right? So 0 to 255. And so map will do that scaling for you. It's super nice in processing. And we can do a similar thing with the green and the blue values. So we can just copy that for green, and instead of X, we can just scale the Y value, and that'll be from 0 to height, right? Onto 0 to 255. And then thirdly, for blue, well, we don't have any more X and Y variables since we're only in 2 dimensions here. But what we could do is just combine them in some way. So we might say X times Y, and that'll be from 0, and then what would be the max of that? Well, if the maximum value for X individually is width, and the max for Y is height, then the max for X times Y is just going to be width times height. So we can say from 0 to width times height, and we're going to scale it once again onto 0 to 255. So what we've done here is calculate all the color values, the red, green, and blue of the color, based on where the ball actually is positionally in the window. So calculate color values, and then we're going to fill, so we're going to tell processing, hey, use those color values when you draw the ellipse, and we draw the ellipse. So let's run this and see what it looks like. Okay, so it's changing. It's getting kind of lighter, greener on the left side, and red up in the side corner. You'll notice that as it gets to the bottom right corner, it gets pretty light, like it starts to get white, which makes sense since the X is close to its maximum and the Y is also close to its maximum, so they're both going to be close to 255. And the color white is represented by 255, 255, 255. But similarly, in the top left corner, you see that it all starts to go dark and it starts to get more black which makes sense because they're all going to 0 and black is 0, 0, 0. So you'll notice that this is looking pretty cool. I think one thing that might make it look even cooler is if we didn't have all those black outlines every frame, because it's kind of makes it more difficult to see the color that the ball is filled with. So one way we can do that is go up and set up just right here below the background, and we can say no stroke, and that gets rid of the outline that is drawn by default around things. So if we run that again, we can see that now it just kind of looks like a line of color moving through space, which is really cool. And also I want to make the background just a bit darker so we can see those colors pop a bit more. But yeah, so I think it looks really good. It's a nice color scaling. You can experiment with other ways to scale the colors. You might use other operations for combining x and y. Like instead of x times y, you might divide or use the modulus, which is a really cool thing. I know that looks cool. I was trying it out recently. And you could do other things, like you could scale the color based on maybe where the mouse position is, so then it would be a bit more interactive with the user, or change the size of the ball based on the mouse position. So there are a whole host of possibilities that you could get into with the coloring of this ball and the style of it while it's bouncing around. So I encourage you to explore all those. But for now, thank you.